Come with me as we have a tour in the world of clocks.
So, this is an example of a quartz clock. It is mainly composed of hands, these three, and a case and a glass. As you can see, there's a reflection of lights and a clock movement. Inside this clock movement, it is composed of different types of gears, different variation of gears in terms of their tips. We will detach the clock movement from the entire clock. So, be careful when you are removing the case and the glass. Then, these are the hands of a clock, the minute hand, the second hand rather, and the minute hand and the hour hand. So we will remove this first, the second hand, for this serves as the cap nut. Ayan. One by one. Then this clock movement. Yan. So this is what we call the clock movement or the clock mechanism. And let's now get through inside it. Okay, be careful. Also, we're removing this one. Be careful for actually I suggest to use a pliers instead of a scissor. So this is what inside of the clock movement or the clock mechanism. It is mainly composed of different sizes of gears, the power source, a metal that transmits the electricity, and also beneath the metal, as you can see there, this one, it's a quartz, and beneath this one, it has also gears. Wait a minute, just careful. This one is for the minute gear, and underneath it is the hour gear also. Okay, I will put it back. Ayan. So okay, I will detach this one. This stuff is a device that spins. First, I'm gonna put a battery. Then, let's try this one. I don't know if it is clear. That's how it works, and let's see how it spins. So I will put a mark on this one to see if it just moves back and forth or it spins around. Okay. It is still not clear if it is spinning back and forth. So let's put it this back. Let's put this back. So since the movement is okay, since the movement is of the transparent gear is moving around, hence the device is spinning around and not back and forth. You're wondering what's underneath of this device. If I remove it, it's just a hole. And this one is a magnet. So let's try if it's really a metal magnet. Oh, it is in fact a magnet, defying the gravity. This, when there's a current, the electricity from this source moves, flow from this to this, and since there's a space, the power is moving around back and forth. It only vibrates the device. And this gear sends the spin beneath this hole. And this gear is for the second hand, and this connects here from here. So underneath this this is for the minute gear and for the hour gear. Yan. I will put this back again carefully. The second gear, this one. Information also, I will give you a very informative information. I will first remove these gears, also this one. As I stated earlier, that this one connects the rotation for the minute's hand. This controls the rotation of the minute's hand. And this is the minute's hand. And the minute's hand is a special one. The reason is that this one. Okay. On this plate, you got this little button that spins like this. Look, as you can see. And it spins the gear for the purpose of quickly setting your clock to whatever time you want. When you spin this very quickly, it modifies the time. However, if you notice that whenever you spin this, the second's hand doesn't move. The minute's hand moves, the hour hand moves, but the second hand doesn't move. It is because this one is connected to here, this one, which spins this gear that also spins the minute's hand. Since we know that this one connects upwards, this one connects upward through this gear, and this gear is connected in the second hand, then why doesn't the second hand spin? It is because of this gear. Despite the fact that this gear looks solid, this one, this layer here, the layer here, is actually disconnected from the rest of the hold. The top layer is steady. Look, this is steady. And I can spin the bottom layer freely. If this part on the in the bottom, there's enough friction going on here that when a clock is usually spinning on its normal operation, the friction will be too high for any slippage. But if I apply a lot of force really quickly like this, then this will slip and the second sand won't be translated to it. That's how special this gear is, because of the friction it has and the disconnection it has also from the gear it connects from. So let's put everything back. For there's also another information that I stated earlier for further discussion. The minutes hand for stability, for the gear that connects the second sand to the minute sand, and for this one. Wait a minute. So if you are wondering why what is about this circuit that makes this stuff always spin in the same direction, and it's just simple. Just watch this. So this is the center of my solenoid, or the main source of power, and this is the center of my stuff. So the magnet, since I already stated earlier that there's a inside beneath this plastic, there's a magnet underneath it. So the magnet isn't contracting. Why is the solenoid is put slightly off this one going here? So that when the pressure of the electromagnetic wave coming out from the solenoid or the main power, it's gonna kick the stuff to the side like this, like that. It's kicking the stuff on its side. If we will detach everything and start from the scratch, it always start from this, the hour hand first, and this gear between the hours hand and the minutes hand, and this plate which consists of the silicon or the main power, the capsule which inside of it is a quartz crystal, and the stuff underneath it is a metal. Then the second hand for the stability, for the gear that connects the second hand and to the minutes hand, and also this gear that connects the second hand and this stuff. So if I put pressure here, you can see that the second hand is moving. So, since this is spinning, since this stuff is spinning 1/2 to every second it takes, and every 2 seconds it does one full revolution. So we can expect that 60 half takes of this equals one complete revolution of this, of the second hand. Or 30 revolution of this is equal to one full revolution of the second hand. That's all. Thank you.